This topic is isomorphism of graph theory, and this is the most important topic in graph theory. See here, in order to say that the two graphs are isomorphic, here is the working rule. First one, both the graphs have same number of vertices, so they should have same number of vertices, and both the graphs have same number of edges. If they have same number of edges in both the graphs have same number of degrees of all vertices. So for all the vertices, they should have equal number of degrees. And next one, it should maintain the minimum cycle length. So if the minimum cycle length of both the graphs are same, and the next thing is vertex preserving, edge preserving, and adjacency matrix should be same for both the graphs. So if all the above conditions satisfies, then we say that the graph G1 is isomorphic to G2. See here, one by one. So first we have to go with vertices, and next one edges, and we have to check all the degrees, and we have to find out the minimum cycle length, and next one vertex preserving, edge preserving, and adjacency matrix. All these topics I'll explain you. And now here is an important question on isomorphism. See here, verify whether the given graphs are isomorphic. This is graph G1 and this is graph G2. So first one, in order to tell that the two graphs are isomorphic, first we have to go with vertices. So how many number of vertices are there in G1? That is V1, V2, V3, V4, V5 and V6. Total 6 vertices. Vertices are nothing but the dots. See here, the dots are nothing but the vertices and the lines are nothing but the edges. And see here in this graph, how many number of vertices are there? U1, U2, U3, U4, U5 and U6. So in both the graphs, we have same number of vertices. So the number of vertices in G1 are 6 and in G2, the number of vertices are 6. See here, in both the graphs, we have same number of vertices. And next coming to the edges here. So there are two figures or two diagrams here. So we have to find the edges. See here, V1 to V2, V2 to V3, V3 to V1 and next one V1 to V5, V5 to V6, V6 to V1, V6 to V4 and V4 to V2. How many number of edges are there? See here, if you see the number of edges here, so lines have drawn here edges. So we have to count this 1, 2, 3, 4, 5, 6, 7 and 8. In this figure also, in this diagram also, this is 1, 2, 3, 4, 5, 6, 7 and the middle one is 8. So the number of edges are 8 in this graph G1 and this is graph G1 and here also in the graph G2 the number of edges are 8. Therefore, in both the graphs the number of edges are same, the number of vertices are same and next we have to go with the degree of the vertices. See here how we have to find the degree of each and every vertex. V1, so the degree here is 1, 2, 3, 4. See, they are 4 edges which are coincident with vertex V1. Therefore, the degree of V1 is nothing but, see, for the vertex V1, how many edges are there? 1, 2, 3, 4. Therefore, for the vertex V1, so we have 4 as degree. For vertex V2, see how many edges are there corresponding to V2? 1, this is 2 and this is 3. Therefore, the degree of V2 is 3 and for V3, there are only 2 edges, 1, 2. So the degree is 2 and for V4 also 1 and 2. So the degree of V4 is 2 and for V5 1 and 2. The degree of V5 is 2 and for V6 see here 1, 2, 3. So the degree of V6 is 3. And next one coming to U1. So how many number of edges are there corresponding to U1? This is 1, this is 2, this is 3 and this is 4. Therefore, the degree of U1 is 4. And next coming to U2, the number of edges 1 and 2. Therefore, the degree is 2. And for U3, 1, 2. The degree is 2. And for V4, 1, 2, 3. The degree of V4 is 3. And for V5, 1, 2, 3. So the degree of U5 is 3 and for U6 1, 2. They add 2 edges. Therefore, the degree is 2. Therefore, now see here. the number of vertices having 4 as degree. So how many vertices has 4 as degree? 1. Here this is 1. And see, the number of vertices having 3 as degree. How many vertices have 3 as degree? This is 2. And how many vertices having 2 as degree? So 1, 2, 3. There are 3 vertices which are having 2 as degree. And see, coming to this, so how many vertices having 4 as degree? So only 1 4. So one vertex has 4 as degree. And how many vertices having 3 as degree? This is 1 and 2. Two vertices are having 3 as degree. And see here, 1, 2, 3. So the number of vertices having 2 as degree is 3. See here, in both the graphs, we have the same degrees. See here, the vertices having 4 as degrees 1, 3 as degrees 2, and 2 as degrees 3. Here also 4 degrees. One vertices is having 4 degree, and 2 vertices are having 3 as degrees, and 3 vertices is having 2 as degrees. So 1 2 3, 1 2 3. So this is also same. So now number of vertices are same, number of edges are same, the degrees of each and every vertex is same. And the next thing what we have to do is cycle length. See, the next one is the cycle length. See, this is the figure, that is graph 1. So according to the graph 1, what is cycle? Cycle is nothing but the closed figure, that is v1 to v6, v6 to v5. The first cycle here is, that is v1 to v6. See here, v1 to v6, and again to v5, and again to v5 to v1. So this is a cycle 1. So this is the closed cycle. And the next closed cycle in the graph 1 is v1 to v2, v2 to v4, v4 to v6. So this is v1 to v3 to v4 to v6, and this is again closing. This is v1. This is cycle 2. And the next cycle here is v1 to v2. This is v1 to v2, and again v3, and again v1. Therefore, the cycle length, so the cycle length is, how many edges we have used? 3 edges. So here the cycle length is 3. 1, 2, 3, 4. The cycle length is 4. And next 1, 2, 3. The cycle length here is 3. And the next one coming to the graph 2. So this is graph 2. So according to the graph 2, so we have 2 cycles here, the closed figures, that is u1 to u3, and next u3 to u5. This is u1 to u3, and next this is u5, and again closing u1. And next here is the another cycle here. So that is u1 to u2, next u4, and again closing u1. And see, in both the cases we have, how many edges are there? 1 2 3. So the length of the cycle is 3. So there are 3 sides, 1 2 3 sides, and for this one also 1 2 3 sides. Here the minimum cycle length for graph 1 is, see here, the minimum cycle length. The minimum cycle length in graph 3 is, see here, out of all these, the minimum cycle length is nothing but 3. So this is 3. And in this figure also, the minimum cycle length we have to check. That is the minimum cycle length for next graph 2 is nothing but 3. So in both the figures, or in both the cases, we have the minimum cycle length as 3. So first one we have checked the vertices, edges, degrees, and next one is the cycle length. And the next one is vertex preserving. See, let me show you what is vertex preserving. See here, this is the most important but easy to understand. So first one here, what is the vertex preserving? So we have to go with the highest degree here. So what is the highest degree here? 4, 3, 3, 2, 2, 2. Oh, among all these, the 4 is the highest degree. I'm going with V1. So V1 has the degree length as 4. So here the degree is 4. And next we have to go with the 4 degree here. So what is 4 degree here? The degree as 4, vertex with the degree as 4 is u1. So I am going with u1. So this is u1, and having how many vertices here? 4 vertices. Again 1, 2, 3, and 4. So 1 is with u1, and the next one is with u3. See here, u3, and the next one is with u4, and next one is with u5. See here, the degrees also we have to check. I'm checking the degrees here. So U1 has how much degree? 4. So this is 4, and U3 has 2 as degree, and U4 has 3 as degree, and next one U5 has 3 as degree. So this is 3 as degree. So if you check here, they are the vertices corresponding to V1, which are having the vertices 3, 2, 2, 3. And here also same 3, 2, 2, and 4 we have. See here, for U1, this is U2. So U1 is correspondent to U2, and which is having 2 as degree. So this is 2. So this is nothing but 2. See here, this is 2, 2, 3, 3. Here also we have 2, 2, 3, 3. So we say that U1 is similar to V1. And next one, I'm going with V3. So V3 is having degree 3. So if it is having degree 3, and the corresponding vectors here are V1, this is V4 and V3. So V1, V4 and V3. So which are having 4 to 2 degrees. So we have to go with degree 3 with the corresponding vector here. So this is 3 and this is 3. So here I need 4, 2, 2. So this is 4, this is 2 and this is 2. And again for this also, this is 4, this is 2 and this is 2. So I am going with 4. So this is the minimum one out of U4 and U5. So this is U4. So I am going with U4, and see here U4 degree is 3. 1, 2 and 3. So 2 is with U2. This is U2 and this is U1, and this is again U6. And therefore for U2 the degree here is 2. See here, for degree here is 2 and this is 4, and for U4, U6 this is 2. So we got the similar degrees, that is 4 to 2, and here also 4 to 2. Therefore U2 is similar to U4. So this is U4. So this one is done. U1 is done, vertex preserving. And next one here, V1 is done, and next V2 is done, and next we have to go with V3. So V3 has two edges. One is V1 and this is V2. V1 and V2. So this is 4 and 2. Here for V2 has a degree 2. So I'll go with degree 2. So they are 4 vertices or 3 vertices which are having degree 2. So I need 4, 3. See here, if I go with this, so this is 3. So degree 3, and next one, this is 3, 3, 3. So I need 4, 3. So I have to go with this. I have to check with this. So this is again 4 and this is again 3. So this is also okay. And next this is also 2. So this is 4 and this is 3. So out of U2 and U3, U2 is minimum. So I am going with U2. So U2 has 2 as degree. So I have to go with 2 as degree. See here, U2 has, this is U1 4, and next this is U4. So what is the U1 degree? So this is 4 and this is 3. So got it? 4, 3, 4, 3. So V3 is similar to U2. And next one coming to U4. So so V4 has 2 as degree. So this is also done. So U2 is also completed. So U2 also I am crossing it. And 1, 2, 3 is done. So we have to check with this. So we have to go with degree 2. So this is 2 and this is 2. So I need 3, 3. See here, if you check with this 2, so this is 4 and this is 3. So I need 3, 3, not 4, 3. So I'm going with this one. So this is 3 and this is 3. So I'm going with U6. So U6 has degree 2, and which is having U4 and U5 are the vertices. So here U6 is having degree 2, and this is U4 is having, see here, U4 is having degree 3 and U5 is also having degree 3. So 3, 3, 3, 3. So U4 is similar to U6. and this one u6 is also done. U6, so this is also done. 1 2 3 4 are done, so we have to go with this. So this is u5, so this is 5, so 5 is having degree 2, so this is having degree 2, so I have to go with degree 2. So 5 is correspondent with 4 and 3, so I have to go with 4 and 3. So u5, so if I check this, it is having 4 and 3. So this is having, so this one is, another one here is 2. Only 1 to remind. So this is u3. So I am going with u3 and it is having degree 2, same as v5, and it is correspondent with u1 and next u5. So this is u1 is having degree 4 and u5 is having degree 3. So here 4 3 and 4 3, got it? And see here u2 is also having degree 2. Clear? And next one u3 is also done. So 1 2 3 4 5 are done, and next one this is left over. And here v6, v1 v2 v3 v4 v5, and next finally v6. So this should be in order, and this we have to preserve the vertex. So this is v6 is having degree 3. See here v6, so v6 is having degree 3, 1 2 3, and we have to go with degree 3. So this is already done, so we have to go with u5. So this is u5, 1 2 and 3. So it is incident with u1, this is u3, this is u1, this is u3, and this is u6. So here u1 is having degree 4, u3 is having degree 2, and next u5, so u5 is having degree, this one u6, so u6 is having degree 2. So got it? So this is 4 2 2, and this is also 4 2 2. Clear? So u5 is having degree 3. Now u6 is similar to u5, so this is edge preserving. So we have to go with all the vertices in this first graph. So this is graph g1 and this is graph g2, v1 v2 v3, and all the edges we have to plot, and all the degrees also you have to plot, and the corresponding degree we have to check. So this is going with 3 3 2 2, and this is also 3 3 2 2, and here this is 4 2 2, and here also this is 4 2 2, this is 4 3, this is 4 3 3 3 3 3, and 4 3 4 3. We have to match with every vertex with the corresponding graph. So this is also v6 having degree 3, and we have to check the same degree 3, and which should have the degrees 4 2 2. So 4 2 2. So u1 is preserving, v1 is preserving u1, v2 v4 v3 u2, and v4 v6 v5 v3 v6, and u5. And so here this is nothing but the vertex preserving. So we have checked all the vertex. This is vertex preserving. So we have the corresponding vertices here, v1 u1, see here v1 u1 v2 u4. So this is v2, and this is u4, v3 u2, v4 u6. See here v4 u6, v5 u3, and v6, this is u5. So this is, next one is edge preserving. See here how many edges are there in graph g1. So this is graph g1 and this is graph g2, and see if you check here how many edges are there. First one v1 to v2, so this is v1 and this is v2, and the second one is v2 and this is v3, and the next one is v3 v1. So this is v3 v1, and the next one v1 v5. So this is v1 and v5. Next v1 v5 v6. So this is v5 v6, and next v6 v1, and the next one is v6 v4, or v6 v4, and the next one v2. This is v2 and v4. 1 2 3 4 5 6 7 8, they are total 8 edges, and the corresponding edges we need. So we have an edge preserving here. So we have, see here, we have already done v1 similar to u1, and next v2 similar to u4, and v3 similar to u2, and next one is v4 similar to u6, V5 similar to U3 and V6 is similar to U5. Now we have to transform all these. So before transforming all these, so we have, in place of V1 we have to write U1. So this is U1. In place of V2, we have to write U4. Next, V2. So V2, in place of V2, we are transforming in terms of U's. V3, in place of V3, I am writing U2. In place of V3, I am writing next U2. What is V1? This is U1. And next V1. So what is V1 here? This is U1. V5 is nothing but U3, and V5 here. V5 is nothing but U3, and next one is V6 is nothing but U5, and V6, in place of V6 I am writing U5, and in place of V1 I am writing U1, and next in place of V6 I am writing, I am writing U5. I am writing U5. In place of V4 I am writing U6, and in place of V2 I am writing U4, and in place of V4 I am writing U6. So these are the edges preserving. In place of V1 V2, see here, in place of V1 V2 we have U1 U4. See here, similar colors. So these two are the edge preserving. V2 V3. So go with V2 V3, and this is nothing but U4 U2. So this is nothing but U4 U2. So this is so similar colors. And next one V3 V1. So we have to go with V3 and V1, and here U2 U1. So this is U2 U1, and the next one V1 V5. So this is V1 V5, V1 V5, orange color here, and next one here, this is orange color, U1 U3, and next V5 V6. So this is V5 V6, this is pink color, and the next one U3 U5. So what is U3 U5 here? This is also pink color. And next one V6 V1. So this is V6 V1, this is violet color, and U5 to U1, this is also violet color. And next V6 V1 violet, and V6 V4. So what is V6 and V4? This is light green here, this is U6 U5. So these are all the edge preserving. So you have to transform every V in terms of U, and we have to check. So there are 8 edges here and there are 8 edges here. So the edge corresponding to V1 V6 is clearly this one U1 U5, and the edge corresponding to V1 V2 is nothing but the red color here, U1 U4, and V2 V4 is nothing but this is U4 U6. So these are the edge corresponding. So we have 8 edges is similar to 8 edges, and the next one is adjacency matrix. So adjacency matrix we have to check, as we know that V1 preserves U1, V2 preserves U4, and here, and this is the first graph, and here this is the second graph. So from this graph we have to find the edge preservance. See here, first one we have to write in a similar way, V1 V2 V3 V4 V5 and V6, and here also V1 V2 V3 V4 V5 and V6. And then second matrix, what we have to do is, in place of V1 I have to write U1, in place of V2 we have to write U4, in place of V3 we have to write U2, in place of V4 we have to write U6, in place of V5 U3 V6 U5. Similarly here also. So we have to find out this one. So in order to finding out this one, so go with V1. So V1. So V1 has two edges with V2, V2 1, and next V1 is having edge with V3. Next V1 is having edge with V5. So we have to keep 1 with V5, and next V1 is having edge with V6, and the remaining are all zeros. See here. And the next one V2, go with V2. So V2 is having edge with V3. See here, it is V3. Where is V3? So this is V3. And next V2 is having edge with V4. We have to keep 1 here, and it is having edge with V1. So this is 1, and the remaining are all zeros. And next one going with V3. So V3 is having edge with V2, and next it is having edge with V1. See here, that's it, degree 2, 1 2 3 4. And next V4, going with V4. V4 is having edge with V2, and next it is having edge with V6, and the remaining are all zeros. And next one V5. V5 is having edge with V1, and V5 is having edge with V6, and the remaining are all zeros. And next one going with V6. So here it is V6, it is having edge with V1, and this is having edge with V6 is having edge with V5. This is V5, and the remaining are all zeros. Got it? And next one coming to this U1. So here this is U1, and U1 is having edge with U2. Where is U2? Here is U2, and it is having edge with the U3. Here is U3, and it is having edge with U5. And next, okay, in between also there is an edge here. See here in the figure. So U1 to U4, and it is also having edge with U4. And it is also having edge with U4. The remaining are all zeros. And the next one coming to U4. So go with U4. Here is U4. It is having edge with U2. And next it is having edge with U1. And it is having edge with U6. Here is 6. And the remaining are all zeros. And next one coming to U2. See here. This is U2. U2 is having edge with U1. And it is having edge with U4. See here, this is also having edge with U4, only 2. The remaining are all zeros. And next one coming to U6. See, go with U6. It is having edge with U4. See here, this is U4, and it is having edge with U5. And the remaining are all zeros. And next one coming to U3 here. So U3 is having edge with U1. U3 is having edge with U5, and the remaining are all zeros. And next one coming to U5. U5 is having edge with U1. U5 is having edge with U6. Here is 6. And U5 is having edge with U3. So U5 is having edge with U3. And next one, V5 has 3 degrees. So remaining are all zeros. So if you check this matrix, see here is a mistake. So V6, if I go with V6 here, so V6 is having 3 degrees. One is with V1, one is with V4 also. So here also V4 also 1. Now if you go and check with this matrix, both the matrices are same. This is 0 1 1 0 1 1. See, this is 0 1 1 0 1 1. This is 1 0 1 1 0 0. So these two are similar to each other, and therefore all the 7 cases. So first one, number of vertices, number of edges, cycle length, degrees, and next vertex preserving, edge preserving, and next one adjacency matrices are all same. Therefore we say that the graph G1 is similar to graph G2. So G1 and G2, or else G1 is similar to G2, or G1 is isomorphic to G2. So this is how we have to solve. Thank you so much for watching, and if you really like this video, this is the most important question, problem, and expected question. So please pass it on to your friends and subscribe to this channel and support this channel for more videos. Thank you so much.